Hey guys, welcome back oh my gosh, I keep forgetting my intro. Hey guys, Mantis here, and welcome back to Human Resource Machine. Let's see. How close are we to the end? We're on level 20 out, the numbers disappear. I think we're about halfway. That's pretty good. I'm guessing there are 40 levels, not including the side ones. So, as I recall, we left off on a somewhat difficult problem. Oh, multiplication. Okay. Yeah, okay. So, let's see if I can remember what my plan was that I did not explain at all in the last video because I was just sort of thinking about it. Okay, so, we need to multiply the numbers. So, for each two things in the inbox, multiply them and outbox the result. Okay, so multiplication is adding X number of times. So the first two numbers here are 9 and 3. So 3 times 9 is 9 plus 9 plus 9, which is 9 added 3 times. So we need to create a loop that will go through it the first number of times, or the second number of times, it doesn't really matter. We need to make a loop that will go input number of times and add the second number that many times. So, let's see. So let's start by taking the input. I'm gonna just remove everything here because I don't need that. Although I'll put this in because we always have that. Alright, so let's copy that to the first thing, and let's use the naming, because we might as well. What? Oh. You have to draw? Why? Okay. I'm gonna use a right arrow as input. So, actually, no, it's not input. 1. Actually, I can just use the numbers then. There's no point in doing this. Okay. So, let's see. So the first input, so we'll copy it to 0. That'll be the one that we'll use for counting. Actually, I'll name it count. This is really inconvenient, but that's how I'm gonna do it. Okay, so it looks like it adjusted for the size a bit of my drawing out of the range of the box. Anyways, so the first number is our count. So then we need to take the second number, and I'll name this value. Okay, and store that in value. So that's 1 already. So now we need to create some sort of loop. So first we need to check if the count is 0. So let's I'm just not gonna worry about being inefficient. So the count, load the count. If that is 0, we will jump to the end. Otherwise we'll come back and do a weird loop thing. Okay, maybe I should start using these comments. So, oh, they're also like this? Okay, that's really bad. Oh, that's undo button, okay. Alright, this is the initialization. Loop. Oh god. This is the start of our main loop, and I'll put end right here, so end there. Okay, perfect. I like how it looks kind of like a comic just because I'm drawing with a mouse. I could just grab my tablet and then use that, but I'm lazy. Okay, so if it's 0, we'll just output the value. Okay. So if it's not 0, alright, so let's see. If it's not 0, which will go right here, I'll move this here just so we can remember that a little better. Okay, so if it's not 0, as I've said like 5 times already, we need to subtract 1 from the count and add the value, the original value to itself. So we need another storage. Oh. Okay. Null. Perfect. This is actually kind of entertaining. Okay. Copy it to original, and we'll copy it to the value. We may need to subtract 1 from the count right off the bat because we already have 1. We have the value, or the original value to start with, so that's 1 times the count, and if it's 1 times the count, or if it's 1 times a number, then we're already done, so we need to subtract 1 from the count at the start. So copy from count, and then we don't need to copy from it to do this part, so okay, so it'll, no, we want to decrease it though. Alright, so subtract 1 from the count, load the count. If it's 0, it will go to the end, so 1 times something will be itself, so it starts with 0, because 1 times 1 minus 1 will be 0, so it'll jump if it's 0, and just output the number. But if it's not 0, we want to, in the end, we want to subtract 1 from the count, and we want to add the original to the value. So we need to copy it from, we need to copy the original value, and then add it to the current value, and then this is actually a lot easier. These notes were a lot more useful than I was expecting. So we need to copy the original value, add it to the current value, and then we need to save it as the new value. And then we already have it in our hands, so we, oh wait, no, because we're bumping the count. So let's start with this, because then we can just not have to reload the value. So we'll bump the count first, and then do all this calculations. Okay, I think this should work. Let's see how it goes. 9 is the count, 3 is the original value and the value. Alright, so that's now 8. Oh, what? Oh, okay, because we initialized it. And then we do the subtraction first. So I'm gonna fast forward through this. It's kind of confusing because the order is a little bit out of order, because as a human I would count it after completing it, but this program counts it before completing it. So let's see. 9 times... Hey, wait a second. There's a mistake here. Alright. So, it looks like we're loading the, okay, so we need to load the count every time. We forgot to do that, because right before it was just checking to see if the multiplication was equal to 0, but we want to check if the count's equal to 0, because I forgot to reload the count when we were checking if it's 0. So now it should work. Let's see how that goes. Oh, 1. That's simple. Okay, 1 times 3... that's 0, it's 0, so it'll, oh no! Now we need to, since we're now holding the count at the end, we need to load the value. I was trying to do a bunch of optimizations and it just didn't work out. This is why I don't bother with it in all the other ones. So now we can just copy it from, I'll put it at the end here. Copy it from the value, And now it should work. That's how it always goes. Now it should work. Now it should work. Alright, it is really satisfying to see it work, though. Alright. Alright, so that's 1. And now it should be 9. 3 times 3 is 9. Now we've got our 9. Nice! Yes, we did it! That's the first one. Now it should just overwrite these values completely. 1 times 7, 0, so 7. Alright. Sweet! Oh, times 0. What happens with 0? I guess it worked. I kind of want to see what happens with the 0 count, though, because I don't think that's gonna work. Uh-oh. Didn't think about that. It says don't worry about negative numbers, but we gotta worry about 0 still. So... Alright, so let's just put a thing back here before we bump it. We need to load the count. If that's 0, we can just skip everything. Oh wait, yeah. Because if it's 0, then we're gonna go negative immediately, and it'll never get to 0. We just need to output 0. And since it's 0, we're already holding 0 at the end here. Although actually, then we need to... Oh, okay. I'm gonna make a little... Okay, so in assembly, this is generally how it works. We have... You can do it all at once like this, or you can create a function, which is what I'm gonna do right now. So, if it's 0, so this is the main loop from the top to the bottom. I'm gonna do something outside of the loop now, and this is kind of like a function. So, if it's 0, let's just ignore this loop and do our own thing. That's what it means. And then, so, we need to... Then we can just send it to the outbox. Because we already have a 0 in our hands from the if 0. Because 0 times anything is 0. So then we can just jump all the way back. It's a really simple function, but I mean, does the job. So yeah, it'll just skip out of our main loop and do a little output 0 immediately thing. Oh, and we have the 0 here if we need it, but I mean, we already, if we need a 0, it comes with the problem, so we won't need to be using this. Alright, now let's try it out. I'm gonna fast forward through this. It's a very long process. Doing multiplication without anything. Alright, the next one is 2 times 0. I missed this one. I want to see what happens with the 2 times 0. So it loads that, does that. It adds 0 to 0. Okay, that makes sense. That makes sense. It's actually multiplying it, but it's like adding 0 plus 0 4 times, which is inefficient, but it works. Alright, and this is 0, so it just skips all the way to the end of our program and puts it out. That's cool. And it skips having to go through loops and stuff. Alright, we got it. I'll just fast forward through this. It's so satisfying to watch that. Like, everything, you do it. You made everything. That's what's great about programming, in my opinion. A lot of steps, though. That was really inefficient. Oh well. I can't even think about trying to make that faster right now. Okay. And let's go up this path here. Fibonacci visitor. Ooh, are we gonna do the Fibonacci series? That's a fun one. This back hallway is for advanced employees only. That's me. Are you sure you want to be here? Yes, I am. These night shift assignments are optional, you know? Yeah, and they are difficult. Alright, it's just telling me I don't have to do this. If you need to ask me, I'll just be here looking through these catalogs for something. I should have looked at that. Alright, I know what the Fibonacci series is. For each thing in the inbox, send the outbox the full Fibonacci sequence up to but not exceeding that value. for example, if inbox is 10, the outbox should be those first few. Okay. What is the Fibonacci sequence? Ask your boss or a friendly search box. Yeah, alright. So, let's see. This should be pretty easy. I'll start with naming some variables. So, this will be the max value, which will be the input. So, I'll start with our loop. Input to the max value. And then we'll just compare those with the subtract and jump if negative, and that'll basically be a if it's less than. So that's the max value, and then the Fibonacci series, if you don't know, is 1, you start with 1, and then you add 1, or so you have 1, and then the next number is 1, and I mean you can't, it's just, that's how it works. And then you add the two numbers in the series, and that becomes the next number. So 1 plus 1 is 2. It's over here. 1 plus 1 is 2. And then you add the next, the last two numbers again, and that becomes the next number. So 1 plus 2 is 3. 2 plus 3 is 5. 5 plus 3 is 8. 8 plus 5 is 13. 13 plus 8 is 21, and so on. And these numbers tend to show up in nature a lot, apparently, for some reason. Anyways, so I will have to calculate that every time, because we have to have the outputs like that. So let's see. First, we need so we need to have all of the sequence. So we need to have 3 numbers in the sequence at a time. Or maybe just 2, because we only need to add the last 2, and then they become the next one, but we might have to have a temporary variable to move them around with. Yeah, okay. So, A1, A2, in math, A means sequence, or series in, series value. So okay, and that's just going to be relative to wherever we are in the series. So okay, so we need to start with A1, and we need to do some initialization because we only have a 0 here, and we need to start with 1s. So we'll start by setting A1 and A2 as 1. So we'll copy from 0. I'm just gonna do that again. That was helpful on the last one. Okay, that's a bad E, but whatever. And yeah, I wrote my E's backwards. Okay, so we need to copy that to A1 and A2, and then we need to increase A1 and A2 by 1. And then we have 1 and 1, and we have an empty one here. Okay. And these shouldn't be 0. I'm just gonna assume there are no zeros that are ever gonna come up here, because there's nothing less than 0. Although it could be 1. Let's see. Not exceeding that value. That's important. We need to not go over the value. So if it's, if it were to be 3, we would only have to go up to 2. Okay. But I'm just not gonna worry about that for now. So, here, let's do the init. A-N-I-T. Okay, that's the initialization. Now we will do the main loop. So that's not an L. Why did I start with that? Oh, okay, I'm gonna do that again. O-O-P. Alright. So now we need to do we need to start with the comparison, I guess. So which number do we need to output, though? We need to think about what we're going to do. So every time we need to go... so A1 plus A2 is A3. And then we'll move A2 to A1 and move A3 to A2. And then we have to compare A2 with the max value. and if it's greater than the max value, then we need the last one, the previous number, because we don't want to have it exceed the value of the input. So the output will be A1. So we'll copy, so load A1, and that will be the output at the end of the loop. Now we need to do our little loop here. Our while loop. Okay. So, what do we need to be 0 is the question. No, we need a jump if negative because we're doing that instead, because we're doing a compare rather than an equals, or we're doing a greater than or less than instead of an equals. So, we need to, let's see, does this store the value? The result goes into your hands, okay. So we don't need to store the value because we only need this for this one section. So we need to load this one and subtract the max value. So if this one, let's say, is 8 and this is 7, 8 minus 7 is 1. So we need to do it the other way around, actually, because we want it to be negative if A2 is greater. This would be an if it's greater than, but we need an if it's less than, so we need to just switch these. And then if it's negative, go grab A1 and output it. Okay, this is good. Now we just need to program the Fibonacci series. Is that? Yeah, Fibonacci. I just questioned the name of the series for a second there. Okay. So I'll put that in. Series. That's a nice E there. Alright. Perfect. Okay. And I might as well put this in. Okay. And okay. Alright, so now we need to just do the calculations for the series. This should be the easy part. We just load A1, add to A2. Actually, since we're holding it in our hands, we don't need this temporary value. Do we? No, we still do, I think. Yeah, we will. Okay. I was just thinking, I don't know. I'm trying to think of things that we could do. Alright, so A1 plus A2 will be A3, or A3 is equal to A1 plus A2. That's what this does. Now we need to move everything over, so we'll copy from A2, put it in A1, and then copy from A3 and put it in A2. So now we've shifted everything over, and then we can do the comparison again. That should be it, I believe. Let's see how it goes. Alright, so 21 is the max value. Doing some initialization, make them 1s. Alright, so 21 and 1 is positive, so it'll increase the series. Adding those and then move everything over. Now it'll compare those again. And then it's not negative, so it'll increase it again. So we've got... Oh, we need to output the series, though. I forgot that completely. Okay. So, for every... We don't even need this. We can just put this over here. I believe, because we need to output each part of the series. Anyways. And we should put it here so we get both 1s, because this will, after this, we'll have just 1, 2, 3. But we need to output 1, 1, 2, 3, it says. Yeah. So we'll take the output. We don't need 2 copy froms, so we can do that. Output it and then add it. Okay, let's see how this goes. Do some initialization. Compare them. Alright, grab the first number. Output it. Hey, what? Oh, okay, because we've outputted it, we need to copy it again, which is dumb. Fine. Okay. There we go. Initialization, compare, it's greater than 0. So it'll output that, and then add them, and then move everything over. Now to compare them, output the next number. 1, 1, 2, 3, 5, 8. And it wasn't greater than... Oh. Hey, wait a second. Wait a second. Okay, so after this, we do need to do the copy from once more because it'll just exit the loop if it's negative, if it's on the correct number. Or we can compare the current number. That would work. We can compare this digit instead, and then it'll just go one more. Let's see how that goes. So we need to get everything up to but not including 8. So the jump if negative should work with that. So the next one is 5. And the next one will be 8. So let's see. It's calculating the series. 8 minus 8 is 0. It's not negative though. Okay, actually I think it will work. So shift everything over. Now it's negative, so it'll just skip it. Now we do this again. Let's see if it gets this part right. See if I made a mistake. Yes! We got it! Haha! That is so fun. I love the fast motion, just doing all this running around. Each of these is like one tick on your computer, so imagine in your computer, like in my computer that runs at 4.5 gigahertz, it's doing that, it's doing each of these steps, it's doing, giga is billion, so it's doing 4.5 billion of these instructions every second. That's what that means. Jeez. Wow. Like, it's just crazy to think about. Anyways, looks like we've run out of time for this episode. Thank you guys so much for watching this episode of Human Resource Machine. I hope you enjoyed. Don't forget to comment, rate, subscribe, give me suggestions and what games I should play, and I'll see you in the next episode. Over and out.